Welcome to Chapter 1. We're going to start off by just defining exactly what chemistry is and talk about some of the principles and methods that are going to underlie all of the material that we cover through this course. We'll start by asking, what is chemistry? And so our terse answer is it's the study of matter. Okay, great. Well, what's matter then? Matter is anything that has mass and takes up space. Okay, so functionally what this means is it's stuff. Generally, in a chemical context, we call samples of matter chemicals. A chemical is just any sort of sample of matter. And so has mass and takes up space. So examples of that would be things like, we can get fancy. We got some nice rings. There is the metal here. There's the gems. We can live large. Much more mundane things. Say this scuba diver over here. The scuba diver is matter. The water that the scuba diver is in is also matter. And also you can see these bubbles up at the top that are coming out of the diver are also going to be matter. You can see that they are taking up space. They fill a space within that water. They may not have a lot of mass, but they do have mass. And so importantly, basically everything you interact with on a day-to-day basis is matter. And so chemistry is really going to be studying the stuff that the world is made of, that the world around us is made out of. One of the few things that's not matter that you interact with every day would be things like light and heat. So energy is not matter, but don't worry, we'll talk about how energy interacts with matter. So we'll group that in chemistry. We get to just study basically everything. So I want to take some time to define some concepts that underlie that matter definition: mass, volume, and weight. So mass is how much stuff is present in a sample. So we said that matter has mass, and so this would be that there is something present there, that there is not emptiness, there is some sort of stuff that is present. Volume, on the other hand, then corresponds to how much space it takes up. So mass is a count of how much stuff is present, whereas volume would be how much physical space it takes up, sort of three-dimensional size of our object. So you could have a certain amount of mass. It could be either a really big thing with a large volume, or it could be a really small thing with a smaller volume. But mass is counting how many things are actually in there. So we don't really normally, when we think about, say, measuring like how big a person is, we use weight. But weight is actually the amount of gravitational force acting on a sample. So gravity, so weight, like the weight, your weight, or the weight of a car or whatever, is how much force the Earth is exerting to hold that object on the Earth. And so more, bigger things that have more mass have a higher weight. But we tend not to use weight in the chemical context, or really in like a scientific context, because it depends on gravitational force. That does depend then on what planet you're on, and we'd prefer to be more general than that. So we're going to use mass, which is just a count of how much stuff is present. Now, technically, we're using functionally weight to accomplish that on a balance. But mass, we're going to compute. We're going to get mass values to tell us how much stuff is present, because if you end up working for NASA and become an astronaut, your experiments in space would work the same way as experiments here, or if eventually we start living on Mars, it will all be the same. We won't have to worry about, well, what's the gravity that you're dealing with. So if we want to talk about chemistry, we said it's this idea of studying everything that's around us. And that really is true. It's studying matter. And so this is a graph or a chart from a different book that's talking about how important chemistry is. And it really is a central science. A lot of you are probably not in this class because you want to go on to become chemists, but because you want to go on and study another aspect of science. And chemistry really is a central place, or has a central role in those other sciences, because if you're interested in studying, say, living things, well, you need to understand the chemicals that make up those living things. If you want to study geology, the chemicals that make up those rocks are a big part of it. Chemicals that make up stars for astronomy. Physics and engineering, the objects that you're looking at changing are still matter. They're made of chemicals. And so the idea of this course is we're going to talk a lot about the basic language of how we work, how we talk about chemicals, how we think about them, and how we process information about those chemicals. And so that's why you have to take this class to kind of work through those ideas and get that basic language. And so it'll branch out into anything else. If you do want to continue into chemistry, there is kind of these different realms and types of chemistry: analytical, moving on, inorganic, organic, or the best one, physical. And so, you know, there's these different kind of applications, more specific, a little more focused on what it is that we're doing. And we're going to kind of sample a lot of these. We're not throughout the semester, mostly inorganic, physical, and then a little bit of analytical from lab work. But, you know, these ideas, we will kind of sample a little more into learning about, you know, kind of a little more focused aspects of chemistry. And applied, kind of really looking at specific areas.